Good morning, girls. Today we are going to discuss about some topics with this lecture. First topic is an encoder. An encoder is a logic circuit which has 2 power n address lines and n output lines, which performs the reverse operation of the decoder. Here we are going to see an example of 8 to 3 encoder, which has 8 input lines and 3 output lines. Any one of the input level will be high. Based on that, you will be getting the corresponding binary equivalent output. Truth table and the block diagram of 8 to 3 encoder. Here, the input lines are marked as I0 to I7 and the output lines are represented as A, B and C. Initially, I1 will be high, remaining lines will be 0. Further, the binary equivalent output is 0, 0 and 0. Next, I1 will be high, the remaining lines are 0. Further, the binary equivalent output is 0, 0 and 1. Similarly, you will be getting the binary equivalent output as 0, 0, 0 to 1, 1, 1. This is the circuit diagram of 8 to 3 encoder. Here, we can see that the output lines, whichever the minterms are actively high, so that is I4, I5, I6 and I7 are connected to an 4 input OR gate. Next for B, we can see that I2, I3, I6 and I7 are connected to an 4 input OR gate. For C, I1, I3, I5, I7 are connected to an 4 input OR gate. This is how we can draw the circuit diagram of 8 to 3 encoder. Next, we will see full subtractor. A full subtractor is a logic circuit which performs 3-bit subtraction. That is, it has 3 input lines, that is A, B and C, and the output lines are difference and borrow. Using binary subtraction, it will be subtracting 3 bits and gives the output as difference and borrow. Difference expression is A exclusive B exclusive C and borrow expression is A exclusive B the whole bar into C plus A bar B. This is a block diagrams of full subtractor using 2 half subtractors. This is the truth table of full subtractor. Difference output lines are 0, 1, 1, 0, 1, 0, 0, 1. Borrow is 0, 1, 1, 1, 0, 0, 0, 1. Circuit diagram of full subtractor using 2 half subtractors. Memory. Memory is usually divided into 2 types, that is internal and external memory. External memories are used for a long-term purpose, for example, floppy disk and hard disk. Internal memories which is stored within the device. The 2 types of internal memories are ROM and RAM. ROM is read-only memory and RAM is random access memory. Internal memory uses semiconductor devices which is called semiconductor memory devices. Usually, the memory cells are made up of cells which can able to store 0 or 1. The capacity of memory will be raised to 2 raised to some integer value 2 power n cells example. In each cells it can able to store 1 bit, 2 bits etc. up to 8 bits. The word ROM represents it can only read the data which is already stored inside the memory. This can be done in the manufacturing section itself. ROM chip is organized in the form of a matrix form, that is rows and columns. At the junction of each row and column, a diode is fixed and give an output of 0 or 1. Let us see the example of 4 rows and 2 columns. The rows are marked as R0, R1, R2 and R3 and the columns are marked as C0 and C1. Each column is grounded to a resistor. The rows and column do not touch each other. The junction of row and column is connected by a diode or a transistor. Here we can able to see the address and data lines. These are the address lines, that is R0, R1, R2 and R3. Columns are C0 and C1. The address may also be represented in binary as 00, 01, 10 and 11. To access core memory location, 2 address bits are required. A decoder can also be used to achieve this operation. Presence of this diode represents a 1 and the absence of a diode represents a 0. Here, we can able to see the circuit of this matrix form. That is, if the diode is connected, it represents a bit 1 is stored. If there is absence of a diode, it represents 0 bit. Similar way, this is how we are getting the truth table. Next, PROM. PROM stands for Programmable Read-Only Memory. The data can be modified. In PROM, diode or transistor is included in all the junctions with fusible links, that is, which can be fixed with the diode or transistor read as 1. You have to blow out some fuses by causing the larger current. This enables to read the particular row and column as 0. It is using a PROM programmer, which is a computer microprocessor based device. A PROM can be changed only once. This can be overcome by EPROM, that is electronical PROM, erasable PROM. This is the circuit of your PROM. So you can see in all the junctions a transistor is placed. So which shows 1 is stored in all the junctions. This can be fused. This fuse can be blown out using a high current. Next is PLA, that is Programmable Logical Array. This is similar to a PROM, which uses a decoder and a multiple input OR gate. In PLA, the input and the complements are connected as inputs to AND gates. As in PROM, the outputs are taken through OR gates. Whereas in PLA, the inputs to OR gates are reduced. That is, the decoder uses 2 power n outputs, whereas PLA uses 2 into n output lines. If the input increases, then it will be useful. Let us take a simple example for the expression f equal to ab plus a bar b bar. Here you can see the input lines and the complements are taken out. So all the input lines are connected to an individual AND gate, and the output lines of the AND gate are given to an OR gate. So this is the diagram. Here, for the expression of f equal to ab plus a bar b bar, so whichever output expression is needed, that is a, b, is passed on to an AND gate, that is given to an OR gate. Next, a bar, b bar. So a bar and b bar is passed on to the next AND gate, and the output is given to an OR gate. So this is how you will be getting an PLA circuit. Here, next is programmable array logic. Programmable array logic is similar to PLA, except OR gates are fixed and permanently connected to set of AND gate output lines. Therefore, the NAND gates cannot be shared. Separate AND gate must be used for each product. Example, F1 equal to A bar B bar plus ABC and F2 equal to A bar B bar plus AC. In this circuit, you can see for each expression, individual AND gate is used and it is passed on to the OR gate. So A bar B bar is a separate AND gate. These AND gates cannot be shared as in your PLA. So this is the difference of your PAL circuit. Thank you girls for this patient listening.